item of maintenance. You're gonna see a lot of fire stuff. It's gonna be really cool, really fun. Now, yes, fire can be fun, cool, useful, all that stuff, but I'm sure a lot of you know, fire can also be very, very dangerous. Yeah, exactly. So, I know you already know this, but do keep it front of mind. I am a trained professional, and there's a lot of people around who have gone through a lot of lengths to make sure everything here is safe. So, if anything you see here today inspires you to want to learn more about fire or science, do more of that stuff, scale down hopefully, great. Just please, please, please make sure you go through the necessary steps to educate yourselves on how it can be dangerous and therefore how you can be safe, right? Because nobody likes to end up in a hospital. So, just for example, we have a couple safety measures right here. Goggles, right? And if I forget my goggles are up here, what do you have to yell? You guys are great. Good, good, good. A couple of things. Keep my hands protected because we'll be using flammable liquids and fire. We got some gloves. Kind of cute, actually. I like this. Big fingers. Fire extinguishers, one on this side, one on this side. Does anybody know how to use a fire extinguisher? Great. Okay, it's not rocket science. Quickly, pull the pin, squeeze the thing comes out. You just gotta, oh, I'm not doing the thing yet. Good practice, but I didn't get my goggles yet. Squeeze and point at the fire. That's important. Thank you. Fine, let's do it. All right, now, so if I am on fire and can't get to a fire extinguisher, one of you runs up, does that. If though you are really freaked out and you just want to get as far away as you can, fire exit over there. Fire exit over there. Or just run. The building's not very close. It's not going to chase you. Okay, here we go. Let's get started. Not yet. Wait. Okay, I won't forget. How about that? I'll just remember. Okay, so let's get started. Now, the title of this presentation is The Chemistry of Fireworks, right? Now, the reason why I chose this one to start off the prototyping for this new demonstration is because it is for Victoria Day weekend, right? A lot of people like to go out and celebrate by watching fireworks. Also, Canada has a very important day coming up, July 1st. It is our 150th birthday. Please head out and check out some fireworks because they will be epic that year. All right. Now, as beautiful as fireworks are, the thing is if you understand them at a scientific level, what's actually going on, you gain another layer of appreciation. And that's what I'm going to show you today. How do we get the effects that we get with fireworks? Now, there's a few layers to what makes fireworks amazing, right? It is the loud bang. And I would love to show you that, and unfortunately, they won't let me do that because we're indoors. So, and you guys probably value your hearing. The other aspect is the beautiful colors that we get and the effects, right? So I'm going to show you the chemistry of how they actually get those colors. Okay. Now, of course, as I'm sure you figured out, it just has everything to do with what's packed inside that fireworks before it goes boom, right? Different colors have different things inside them. So I'm going to show you one such, one right now. And that is, let me see if I can get it. Aha, not that one. Oh, it's all the way to the bottom, fantastic. Okay, so if we get, there's our fire. Fires come in an array of colors. The common ones are blue if you're getting like propane or something, or orange or yellowy. Okay, but there we go. This one here, I don't need the gloves for this one. Thank you though, I appreciate that. Okay, so if you have a chemical like this one I have here, it's called strontium chloride. You will get perhaps a red-ish flame coming in. So, oh, there's some copper in there, neat. So, yeah, that's a different chemical. That's a bit of cross-contamination there. But don't worry about that. Okay, I'll let you get to the green. So the green is copper sulfate. The red that you saw was strontium chloride. So if ever you see a red firework, what you can do is probably lean over to your friend and say, "Hey, I think it might be strontium." You probably should, because if your friends are anything like my friends, they won't care. Okay. But as cool as that effect is, that's kind of like just the surface layer. Yes, it's a different chemical creating color. But what actually happens at an atomic level to get that color? Well, this is where things start to get interesting. All right, so quickly, atoms. Right, we'll go basically what an atom is. An atom is made of three main particles, right? Strontium is an atom, oxygen, all these things. Okay, the three main particles. First particle goes right in the nucleus of our atom, positively charged particle. This is a proton, right? Next particle Neutrally charged particle goes right next to our proton. It is a neutron, no charge. Last particle is kind of buzzing around the side. It's a negatively charged particle. That is exactly an electron. Okay, there's your basic model of the atom. Now here's the neat thing about atoms, is that atoms can absorb energy. Okay, but when they do, that actually kind of changes the structure of the atom a little bit. These electrons get to an excited state. They go like this. Okay, but they don't stay like that indefinitely. They have to get back to their ground state. So what do they do with that excess energy? Well, they give it off, right? In the form of wavelengths of light. Okay, now depending on the wavelength it gives off, our eye will see that as a certain color. Okay, now some of you can see this more, some of you can't. I won't go too much into this if this kind of turns you off. There's our atom. Electron in the ground state is this first one. If it absorbs energy, it jumps to a higher state. Now depending on how much energy it absorbs, it'll jump to a higher state. All right, I'm gonna show you guys. There, okay, but if it absorbs a lot of energy, like let's say up here, and then jumps back down, it gives away a lot of energy. It then gives off a high energy wavelength, which produces a blue color. Great, right? If it produces like kind of a medium wavelength, by giving off a medium amount of energy, we get a green color. If it gives off a little bit of energy, we get a red color. Now here's the neat thing, is that much like how humans, each and every one of us, has that nice little swirl on the end of our finger that uniquely identifies each and every one of you. What do we call that? Fingerprint, yes, exactly. Every element has its own unique set of wavelengths that it and only it gives off, aptly named a spectral fingerprint, right? So if we have an unknown substance that's burning and we detect certain wavelengths of light from laboratory tests, we know that only one element gives off those wavelengths, therefore we can trace back to that element. We know it is strontium, for example, or whatever, right? So this science helps us identify things just from the light. So for example, okay, our sun. We see it all the time, every day, literally. What gases is it made of? Anyone tell me? Where's it? Hydrogen and helium, exactly, fantastic, thank you. Hydrogen and helium. The thing is, how do we know that, right? Because the sun is really far away. We don't send people to the sun to collect stuff and bring it back. If we did, it's too hot, we'd burn up. The way we know is by analyzing the light that gets to it, and we know that it is hydrogen, helium, and some other ones as well, which is pretty cool. And this allows us to examine the entire universe, which is amazing, just by analyzing the light that gets to us. We're still on an Earth scale too, right? In a laboratory, let's say forensic laboratory, you're trying to solve crime, you have an unknown substance, they will burn it, detect the wavelengths, and trace it back to what that is. It helps us identify substance, okay? Well, let's get right back to fireworks. Okay, now here's where it gets interesting. Not just yet, give me a second, Okay, give me a second. Fine. Shouldn't have done that. Okay, so let's bring it back to fireworks. Okay, so I mentioned that if you see a red firework, you might be like, hey, strontium. Could also be lithium, all right? And also make sure we're not getting onto the stage here as we're flying there. Just give me a moment. Okay, so again, that red flame might be something like strontium. You know what? Actually, can I get your guys' help? We're gonna bring the lights down. Can you guys help me out? Put your arms up. And we're gonna bring the lights down. Ready? Nicely done, guys. All right. So there's a beautiful strontium fire. Okay, well let's say you wanted, let's say a blue flame. You see a blue firework, well that would be something like cupric chloride. Yeah, that is the appropriate response, right? But let's go to those beautiful orange or yellow fireworks. That can be something as simple as table salt, sodium chloride. The sodium chloride burns a beautiful orangey color. Beautiful. But let's go with, let's see, green. We'll get to purple. That'll be the finale. Green flames will be something like, let's get that going. Let's see, copper sulfate will give you a nice green flame. Okay, there we go. Let's keep it going there. All right. Let's see. Oh, you want a purple, right? All right. Let's start with purple. That might be something like potassium chloride. What about yellow? Yellow technically would be calcium carbonate. We don't have a pure enough sample for calcium carbonate, which is really cool. But pink, purple. I'm not taking requests here. Right. Brown. Are you kidding me? No, I'm not doing brown. All right, but different colors, different elements, right, give off different flames based on how much energy they can absorb before giving it away, right? So the colors you might see in a firework are just characteristics of the elements themselves. So here you have a rainbow of flames, or something I like to call a flamebow. Thank you for laughing at that. Somebody laughed at that. And so yes, this is science, not magic, and this is chemistry of fireworks. Thank you so much, everybody, for coming. If you have any questions, please do come out and ask away, or comments, email us. Have a great day, everyone. Thank you so much.